Welcome everyone to my video presentation. Today I'm going to dive into a very fascinating project, a food ordering chatbot. This project is more than just a demonstration of technology. It also attempts to solve a specific problem, how to improve the efficiency and accuracy of ordering processing in a business restaurant environment. Next, I will introduce in details the design process of this project, the technology used, the challenge faced, and my experimental results. In my ordering report projects, I rely on current cutting-edge research in natural language processing technology, especially the application of entity recognition and text phrasing using spice. See, the following are the key technology areas and their associated academic literature. Part 2. The main components and functions of the agent. General NLP model chatbot first use a pre-trained general NLP model species in core web model to handle basic language understanding tasks. This model is responsible for fitting the basic structure of user input, including grammar and parts of speech, such as verb and noun recognition, to help determine the user intent. Customized NLP model. Chatbot also introduced a customized NLP model for language patterns and terminology specific to the ordering scenario. This model is specifically trained to recognize full name qualities and related requests such user-specific dietary restriction or preference. Intelligent user interaction. Users enter their requests through a simple web interface, such as add double fries to my order. These inputs are processed while JavaScript and sent to the backend. After the backend receives this information, an instance of the chatbot class will analyze the text and use the above NLP model to press out key information such as order details and the user inquiries. Integrated order and menu management. Based on the pricing results, chatbot can interact with menu manager and order processor. For example, if the user asks for the details about the menu or a specific dish, chatbot will request the menu manager to provide the information. When the user confirms the order, chatbot will guide the order processor to add the new ordered items and manage the entire life cycle of the order from creation to settlement. Technology and tools. In the process of developing and ordering chatbot, we used a variety of advanced technologies and tools to ensure the efficiency and reliability of the system. Here are the key technologies and tools used in our project. Programming language Python. Python was chosen as a backend developed language because of its powerful library support, which is particularly suitable for data processing and machine learning tasks. Python is also makes rapid development and maintenance possible. JavaScript front-end interactions use JavaScript, which is a standard tool for building dynamic and responsive user interface, allowing us to achieve real-time interaction between customers and ordering chatbot. Frameworks and libraries. Flex as a backend framework. Flex lightweight features made it possible to quick develop web application and RESTful API to facilitate processing requests from front-end. Spicy used to support chatbots' natural language processing capability. We leverage SPACY powerful capability for language press, pressing and processing, including customers' models to adapt the specific needs of the catering industry. Front-end technology, HTML and CSS used to build and design user interface. HTML provides the page structure and CSS is responsible for style and layout, ensuring that the user interface is both beautiful and functional. Through Ajax technology, application can exchange data with the server and update part of the web page content without reloading the entire page, thus improving the response speed and efficiency of the application. Development and testing environment. Since the code is developed inline, we rely on running and debugging the code directly in the local environment. This means that most testing is conducted on the developer's local machine, allowing rapid iteration of product features through real-time code modification and feedback. Use built-in development tools and libraries, PyCharm integrated development environment for code editing, debugging, and testing. Through the comprehensive use of these technologies and tools, our ordering chatbot can not only understand and handle complex user requests, but also run stably during peak periods and handle a larger number of orders. The selection of this technology ensures the scalability and maintainability of the system and is a key factor in the success of the project. Function demonstration. In this demo, we will detail how an ordering chatbot used advanced natural language processing technology to receive and process orders and how this technology can be integrated into our ordering system. Sequential application of natural language processing. Users submit their order requests through the web interface, typing, for example, I want 2 burgers and a Coke. These inputs are first processed by JavaScript and sent to the backend while post a request. On the backend, the chatbot class first uses SPACY general model in core web made for preliminary text pricing. This step is understand the basic structure and semantics of the input, such as identify keywords and num. Next, chatbot further analyze this information use a custom NLP model specifically targeting specific elements in the ordered context, such as menu item names and quantity. This step ensures the accurate pricing of user input, order processing, and dynamic feedback. After pressing the user input, the identified order information is passed to the order processor. Here, the system handles and adding line items and calculating the total process. After processing, chatbot generates an order information message containing all order items, quantity, and total price, and sends this information back to the front-end display through the server. Error handling and user guidance. If chatbot recognizes a verb such as order, want, need, or get in the user's input but fails to identify a specific menu item, it will trigger a specific response. Simple code looks like this. If the pressed verb contains order electron but lacks a concrete object. Chatbot will reply, "Could you please specify what you would like to order?" Such guidance helps users to provide more detailed information. Questions and experimental design. In this paragraph, we explore our research questions and introduce the design method of experiments to evaluate the performance of food ordering reports in the real-world applications, especially its accuracy in understanding complex orders. Our main research question focuses on the ability of an order chatbot to process and under customer orders with a particular focus on its performance when pressing complex order containing multiple items and the qualities. Key questions include list here. Data preparation. Use the train data JSON and text data JSON I provide. This data contains a variety of typical order texts, and each text is labeled with intensities of food name and quality. This data will be used to train and test our NLP model. Training process. Use the training data set to train a custom NLP model. This process involves training the model to recognize and pressing key information in the order text, such as food category and quantity. Texting and validation. Use text data to evaluate the performance of the model. This step will help us to understand how accurate and reliable of the model is when dealing with unseen order data in real-world applications. Evaluation indicators. Accuracy is calculated by comparing the entities recognized by the model with the accurate annotated entities. This includes the correct identification of the boundaries and the categories of entities. We expected that with this training and testing methods, the ordering chatbot NLP model will be able to accurately pricing ordering in most cases. In addition, we also hope to identify possible weakness of the model, such as its performance when dealing with specific language expression or rare dish name, so that the model can be further optimized. Through this experimental design and evolution method, we hope to fully understand the ability of ordering chatbot in pressing complex order and make necessary adjustments and optimizations based on the experimental results to ensure that they can effectively serve customers in actual operations. This part of content will help the introduce how to analyze the training and validation data of our chatbot NLP model to evaluate its performance and what the results may tell us about the model's effectiveness and areas for improvement. Overview of the model training. The model is trained use data JSON that contains various examples of customer interactions noted with entities such as quantity and food. This data helps the model learn how to correctly identify and extract these entities from user input. Evaluation indicators. Accuracy. This is the main metrics and measures the percentage of predictions that exactly match the annotations in the text dataset. In this project, I use loose to replace it. Precision and recall. These metrics are especially important for NLP text. Precision measures the accuracy of predictions. For example, how many of the predict labels were correct, while recall measures the model abilities to find the all relevant cases, how many of all relevant labels the model successfully predict. FE score, the harmonic mean of precision and recall, providing a single measure that balances these two metrics, particularly used for when dealing with imbalance classes common in entity recognition tasks. Result analyze text data performance, calculate performance metrics, loose precision recall, FE score based on the model correctly identifying and labeling entities in unseen text data. Typically, the results will highlight the model's ability to generalize from training to new unseen example. Error analysis. A key part of NLP model training involves reviewing where the model is going wrong. This may include misclassification of food items, incorrect extraction of quantities, or complete failure to identify instance. Understanding these errors can guide further improvements in training data and model architecture. Main finding and implications. Success points highlighting areas where the model performs well, such as correctly handling popular menu items or handling common order formats. Well, key points. Challenge. Discussing different aspects of the model, such as real menu items or unusual order wording, can help identify future areas for data explanation or additional feature engineering. Impact of improvement. If interactive training cycles has been performed, demonstrating improvements in model metrics over these cycles will demonstrate the effectiveness of the model turning the data argumentation strategies. Problem discussion and conclusion. In the last part of this project, I will discuss the research question based on the experimental results of the ordering chatbot and outline the project's success, limitations, and future direction of improvement. Discussion of the research questions. Our main research question focus on evaluating the ability of ordering chatbot to process and understand customer orders. Through experimental data analysis, we found that the ordering chatbot performs well in terms of accuracy and response time, especially in standard order processing, and were able to respond effectiveness and quickly. However, the bot performance declined when processing complex orders that contained non-standard language or uncommon dishes names. This situation often requires more complex NLP model training or more comprehensive data sets to improve the ability of accurate recognition. Project success and limitations. Success. The ordering bot performs well in most standard and simple ordering interaction, effectively reduce manual input errors and improving order processing efficiency. Limitations. There are challenges with both pricing, language diversity, or specific spoke expressions. In addition, the adaptability of the current NLP model to non-routine requests needs to be strengthened. Direction for future improvements. Optimization of models and datasets. In order to improve the ordering chatbot ability to handle complex orders, we plan to expand the training datasets to include more language variants and dish types. At the same time, the introduction of more advanced AMP technology such as deep learning and context-aware models may further improve the accuracy of recognition. Improvement of user interaction. Considering the importance of user experience, we will explore more user feedback mechanism to collect specific usage feedback and optimize the interface design and interaction process based on this feedback. Real-time performance monitoring and adjustment. Establish a real-time monitoring system to trace back the performance of the ordering chatbot, promptly discover the solve operational problems, and ensure the continuity and reliability of the service. With these improvements, we expected that in the future version, the ordering chatbot will be able to more comprehensively meet the needs of users, whether in busy restaurant environments or in scenarios that require highly personalized service. This will help us achieve wider market application and continue to improve customers' satisfaction. This is a reference of the video presentation. This is a bibliography of this project. Thanks for your listening.